All right, y'all. Today we have another new topic for Algebra 2, but we are going to start with a warm-up. We're going to start with a warm-up. So in your notes, please write 1.3 warm-up and then get ready to solve this problem. So this is review, and this is our problem that we need to solve. Use the area model to find, the area model is the box, by the way, to find the product. What does product mean? So really quick, tell me, what does product mean? What does product mean? All right, hopefully you said multiply. Product just means multiply. So use the area model to find the product or multiply these two things. 3x plus 1 times x squared minus 4x plus 6. Okay, so really quick, we're going to start by filling out the outside of our area model. So as a reminder, the outside of your box consists of the two things that you're trying to multiply, and this area model is already set up for you. X squared minus 4x plus 6. So those two things go on the outside of the box. And then you need to multiply the things on the outside to get the inside pieces. So I want you to do this multiplication and then see if you get it correct. So go ahead and try this multiplication on your own. Okay, so let's see, did you get this correct? I'm just going to go through this very quickly because it's review, but please, if you are like struggling with multiplication, please watch every step. All right, so to do this, you do the first term 3x times x squared. We know that it's going to be, we can imagine that there's a 1 on the x squared, right? So we know it's 3 times 1, which is 3, and then x times x squared. This is a 1 on the x that we could imagine, and you add the exponents. So we're going to do 1 plus 2 to get the new exponent on x. So we get 3x, and then 1 plus 2 is 3. So 3x cubed. Now, the next thing I like to do is go over here to the 1 and multiply it times this top term to fill in what goes in this spot. So 1 times 1x squared, that's just going to give me 1x squared. If you want, you can write the 1. If you don't want to, you don't have to. All right, let's go to the next thing. So I'm going to like erase these really quick. Sorry. And I'm going to now multiply the 3x times negative 4x. So 3 times negative 4 is negative 12. X times x is x squared. Cool. Then I'm going to do the 1 times negative 4x. So I get 1 times negative 4, and then we still have an x on there. All right, and let's do the last two. So we have 3x times 6. So 3 times 6 is 18. And then we still have an x because there was an x on the 3. And we're going to do 1 times 6, which is just 6. Okay, cool. We are so close to being done with our multiplication. Now all we have to do is add the diagonals on the inside. So you'll notice that these diagonal pieces should have the same number of x's. Those blue highlighted ones have x squared on them, right? These green highlighted ones have just 1x. Those are the ones that are diagonal from each other. So we are going to combine these diagonals with addition to finish our answer. The 3x cubed and the 6, they stay kind of on their own. So they are outside, and we will say our final answer is 3x cubed. Let's add the 1x squared minus 12x squared. 1 minus 12 is negative 11x squared. Let's add the negative 4 plus 18x. That would be positive 14x. And then last, we have plus 6. Okay, cool. This is our final answer. The inside of the box, make a note of this, please, on your paper, in your notes. Inside of the box is the answer for multiplication. Is the answer for multiplication. That's important for today. Okay, the inside of the box is the answer for multiplication. All right, so since this is our answer, we are now going to write that down here. So we could say that 3x plus 1 times x squared minus 4x plus 6 equals, and it's the inside of the box. That's your answer for multiplication. 3x cubed minus 11x squared plus 14x plus 6. Sweet. Okay, that was a little warm up. Now we're going to do a think about it. Find the quotient. The quotient is the answer that you get when you get division, so that's important to know. Or when you divide, the answer that you get when you divide. Find the quotient below. Use the warm-up and the area model if you think it would be helpful. All right, I want you to try this in your notebook on your own. Look at the problem that we have, and then you should be looking at what we did in the warm-up because I believe it will be helpful. So if you want, I can like zoom out, although I think it's going to be too small for y'all. So hopefully you did the warm-up in your paper. Think about how would you use the area model and what we did in the warm-up to find this quotient, the answer to this division problem. Also, what do you notice about, I'm going to give you a hint, what do you notice about the answer that we got with the multiplication problem and the numerator of the division problem? What else do you notice that they might have the same or similar? I'm giving y'all lots of hints. Okay, so here's what we're going to do. We are trying to find the answer to this division problem. So let's think about really quick. Let's go back to what we did in the warm-up. Let's go to this. What if I was trying to make it look like this? This side, 3x plus 1, or what if I was just trying to make the 3x plus 1 go in the denominator, like it is over here? I would do what operation? So I want you to tell me what operation could I do on this thing to make the 3x plus 1 end up in the denominator like I have it over here. Go. All right. Hopefully you said division. Inverse operation. So here we have multiplication, right? What if I divided 3x plus 1? And that would mean I had to do it on both sides, right? So I divide 3x plus 1. Then it would cancel out on this side. And I would have on this side, I would have the division problem that I'm trying to solve. This is the division problem that I'm trying to solve over here. And I bet you could guess what the answer is now. It's what's left on the left side. But let's break that down into the box now. So when you're trying to find a division problem, you're actually going to use the area model in the same way. You're going to use the area model in the same way that you use multiplication, except you're kind of going to like reverse engineer the box. So let's think about where the 3x plus 1 was on our box. Actually, here. This thing previously on our warm-up, this thing, the numerator, showed up where? Inside or outside the box? The numerator is right here. That was inside our box, right? So let's go ahead and make a note that we need the numerator when dividing. So make this note. When dividing, we need the numerator inside the box. That's always going to be true. We need the numerator inside the box. Okay, and then we can still keep the 3x plus 1. We can still keep this thing on the side of the box. I'm trying to keep my colors consistent, sorry. So I did this in like a blue. The 3x plus 1 can go over here, 3x plus 1. So denominator stays on the outside of the box. And then what do we think is going to be on top? Our answer. So this is actually, this time, your answer is going to show up on top. Answer to the division problem. That's the quotient. Quotient. Okay, so now let's try this. Let's do this. We need the numerator inside the box. So what we're going to do is, this is your introduction to division. What we're going to do is that you need to have this problem on your paper. So please, please make sure you have this problem written down. This is your very first example to division. And again, this 3x plus 1, it went to the side of the box. Just like over here in multiplication, the shorter term went to the side of the box. Okay, here we go. So what we're going to do is we're going to make sure that we have, ooh, sorry, y'all. My tablet is freaking out. Okay, we're going to make sure that we have the answer, or sorry, the numerator inside the box. So the first thing we're going to do is put the first term inside the box, 3x cubed. And we're doing almost the same thing as multiplication, but I say we're reverse engineering it because we kind of have to think backwards now. So what we're going to say is, we're going to think backwards. We're going to say, okay, 3x times what gives me 3x cubed? 3x times what gives me 3x cubed? So we're trying to kind of fill out the outside of the box, and that will be our answer. So 3x times what gives me 3x cubed? 3x times x squared. Okay, once we get this thing, we can now do some multiplication. So here you're going to multiply to get this. Cool? All right, so I'm going back to something on the inside of my box. So now I'm going to multiply 1 times x squared to get this empty space right here. So what is 1 times x squared? That's x squared. Okay, cool. This is where it gets a little bit weird. So make sure you're following along. Okay, now we need, again, when dividing, we need the numerator inside the box. So what we need to do is ask ourselves, the diagonals still have to add. These things still have to add. And this has to be an x squared. We've talked about how the diagonals always have to match. Like you always have to have the same number of x's on the diagonal. So we know it has to be x squared. We know that we need the numerator, this thing, in the box. So the question is, how many x squareds do we see in the numerator? We see negative 11x squared. So this positive 1x squared, and whatever we have here, it has to add to negative 11x squared. So the question is, 1 plus what gives me 11x squared, or negative 11x squared? So 1 plus negative 12. 1 plus negative 12 equals negative 11. So that's how I know negative 12 needs to go in that space. Okay, now that we have that one, we do another reverse engineering. We say 3x times what? Times what? Gives me negative 12x squared. 3x times what gives me negative 12x squared. Well, 3 times 4 gives me 12. It needs to be negative, so I'm going to make it negative 4. And we need another x because we have x squared. Cool. We reverse engineered to get the top. Now let's go ahead and do the multiplication. So we're going to multiply to get this one also. Oops, sorry. I'm trying to keep my colors separate. Answer's in pink. Numerator is in purple inside the box. Okay, cool. So let's multiply. Now we're going to do 1 times negative 4x to get what goes in this space. So 1 times negative 4, that's negative 4x. Cool. Again, the diagonals have to add. We know that this diagonal has to have an x because it has to have a matching term. And then they have to add to what we see in the numerator, the number of x's we see in the numerator. So let's go back up to the numerator. That's right here. And let's look. How many x's do we see? Positive 14x. Okay, so this negative 4 right here, and whatever is right here has to add to positive 14. So negative 4 and what number would add to positive 14? I'm going to say 18 because negative 4 plus 18 gives me 14, positive 14. So that's how I know 18 goes there. All right, now that we've gotten that, we can again reverse engineer. So let's go back over here. 3x times what gives me 18x? 3x times 3 times 6 is 18. So 3x times 6 gives me 18x. And we are almost done, y'all. Okay. Again, we need to multiply. So like multiply to get this one. The bottom rows we multiply to get. So 1 times 6. What is 1 times 6? That is 6. That's going to go here. All right. How do we know if we did this right? How do we know if we did this right? Did you have everything add up to your numerator? Let's check this very last one. We got 6. Was that the last term in our numerator? 6. Look at that. We finished. Okay, the answer to your division, so the answer to your division is on top. The answer to your division is on top. So right here, this is the answer to our division. So we'll eventually we'll say, so this question equals x squared minus 4x plus 6. Okay, cool. I'm going to do one more example and then y'all are going to practice. Like, just so to be clear, y'all, the answer to this problem, I'm going to highlight it in blue. This is the answer to the problem, the division problem that we just did, and that would go right here. You might notice that that answer is right here. And that's because, look, we have like the same thing when we move around these terms. We basically get a division problem. We made the warm-up look like a division problem by dividing both sides by 3x plus 1. All right, let's move on to another example. Cool, so we're going to go to the notes now. Where are they? 1.2, no, 1.3, that's why. There we go. Okay, so really quick, I want you to make this note in your notebook. You're going to need to know this. This is like the language around division. And also write down 1.3 notes, dividing polynomials. We're going to do one more example, and then y'all will practice with me all together. We will do the practice problem. All right, so the first thing you need to do is write down the note about dividing polynomials. That you need to remember that the dividend, if we were going to write it in a fraction form, it's dividend. These are the names of each piece of a division problem. Dividend over divisor equals quotient. It's important to know like what each piece is called because a problem might say, what is the quotient? That just means what is the answer? What is the answer to a division problem? Quotient is the answer. Okay, so you can write all those versions down. Quotient means answer. That's important to know. Dividend is on top. Divisor's on bottom. All right, and let's get one more example problem. And we'll like kind of go through the steps of how to divide. Again, we're reverse engineering multiplication. That's all we're doing for division. Using the area model and reverse engineering it. All right, so here we go. Get this example in your notebooks. Divide 10x cubed plus 27x squared plus 14x plus 5 by x squared plus 2x. All right, and the first thing that I'm going to do is write this in a way that I like to see it. So when I see it in this form, what goes on top? Does the first term go on top? This is a question for you. Does the first term go on top or does the second term go on top when I see it in this form? If I'm like making it a fraction. Okay, hopefully you saw the first term. So the first term goes on top. We're going to rewrite it so that it looks like what we want. It's 10x cubed plus 27x squared plus 14x plus 5 this is the same as that stuff divided by x squared plus 2x. All right, and let's go ahead and start by drawing our box. A lot of students stress about like, how many squares should I put on my box? I don't want you to stress about that. We're just going to start by drawing like, I don't know, a box with like 4 squares. So what I mean by squares is 1, 2, 3. Do you see how this has like 4 sections? We'll start with 4 always. It's probably a good start. And then we'll see if we need more. Okay, what should always go on the side of your box? Tell me what should go on the side of your box. Should you put expression 1 or expression 2 on the side of your box? If you want, you can look up here to answer that question. All right, number 2, expression 2 should go on the side of your box, x squared plus 2x. The piece on bottom, also known as the divisor goes on the side of your box. Okay, now we should have something we start with putting something inside our box. So what should I start with? What should I put inside my box? I want you to tell me what goes here. Okay, hopefully we all said the first term on top, 10x cubed. We're going to start by putting 10x cubed here. And then we're going to reverse engineer to get our answer. So x squared times what gives me 10x cubed? X squared times 10x squared. That'll give me 10x cubed. Now I need to multiply. So I'm going to go ahead and multiply. So right here, I'm going to multiply 2x times 10x squared. That's going to give me 20x. Oh, wait. X squared plus 2x. Hold on, I'm just making sure we're good. Yeah, that's what I messed up. Hold on, y'all. Check this out. I messed it up. What did I mess up? Look. 10x squared times x squared would give me 10x to the fourth. So this is just 10x to the first. There we go. There we go. Okay, and then, oh, we still have 20x here. Squared. Okay, we're good. We're back on track. Sorry about that. So, all I did was I said like x squared right here times x to the first gives me x, or x to the second gives me x cubed. That was fake math. I was doing fake math, so I apologize. X squared times x to the first gives me x cubed. Okay, let's keep going. These diagonals, these things on the diagonal, they have to add up to however many x squareds we started with. So let me look back up here. How many x squareds did I start with? Positive 27. So we have 20. We have 20 right here. We need 27. So I need to add 7 x squareds. Now I'm going to reverse engineer multiplication. X squared times what gives me 7x squared? X squared times 7 gives me 7x squared. Okay, now I'm going to multiply to get this square. 2x times 7 gives me 14x. Sweet. I need these diagonals to add up to the same number of x's I see in my numerator. I see 14 x's in my numerator. So we need 0 x's. We have all the x's we need. Okay, so x squared times what would give me 0 x's? Well, I guess we would say times 0. But this answer, we represent this answer, they're all separated by addition, right? So this is 10x plus 7 plus 0. Do I need the plus 0? No, I don't. So I'm not going to worry when you end with like what you need. So like, let's go back, and I'm sorry if you wrote all that, but you can like make a note to yourself because this is good for you to see. When you end with what you need to like pause. So let's pause right here. We have 10x plus 7, right? We have 14x, that's on the top in the numerator. The only thing is we're missing something from the numerator. The whole numerator needs to be inside this box, but we're missing the positive 5. Okay, y'all. So when you do not end on a number, because right now we're ending with an x. Do you see how we have like an x here? You're not supposed to end with an x. You're supposed to end on like a number, just some random number. When you don't end on a number, you're definitely going to have a remainder. When you do not end on the correct number, sometimes you'll end on the wrong number, you're also going to have a remainder. So here, we're going to put a little r. So note, we have a remainder. I'm just going to make it inside the box. You don't have to. You could put it on the side if you want. And our remainder is how many we're missing. What are we missing? 5. We're 5 away from what we need. How many are we away from what we need? 5. So that's our remainder. And the way you write that in your answer, because remember, your answer is on top, not inside. So the way you write that on your answer is you say plus, and this is kind of weird, so make sure you catch this, 5 over what you were dividing by, whatever you were dividing by, x squared plus 2x. That is how you write your remainder. Okay, so to write our final answer, we're going to like take off of the box because you shouldn't leave your final answer on the box. 10x plus 7 plus 5 divided by x squared plus 2x. That's our final answer. Sweet. All right, y'all are going to do a practice one now. This one is, I think this is a good one to practice, so we're going to go ahead and do that together. Hopefully that feels good for y'all. Good work.